LandLine sweep. Let's talk about it. While there is a growing use of internet communications and cellular in particular, we can still find use of landline solutions, and I believe it will be around still for quite a long time. So we have to address the requirement to check the possibility that these solutions will not serve for eavesdropping activities. And of course, discover it when it is being used for eavesdropping activities. So one important observations I want to do is that when I say landline, I basically mean the analog and digital communication of landline, but this does not include VoIP, voice over IP, to which I will dedicate separate lesson, as VoIP is the most current use technology, but should not be confused with the landline definition. So, however, there are basic procedures that I will show that are essentially the same for both VoIP and data communication and landline communication. And I refer to the procedures of cable check that we will see later. So in most cases, we use the same equipment and procedures to check telephone cables with RJ11 connectors, and to check network cables with RJ45 connectors, or even to check video coaxial cable with BNC connectors. And depending on the equipment we use, we can also use it to check possible other cable types. So there might be, we'll see that there are some procedures that serve for both technology, but we will also see that there are procedures that are specific to VoIP and other procedures that are specific to landline telephony, meaning analog and digital communication, landline telephone. Okay, so let's see first how landline phone works. So landline telephones have been around for over 100 years, and their operation has remained essentially unchanged. If you have an antique phone from the 1920s of the last century, you could connect it to the wall jack in your house and it would work fine. Amazing as it is. The landline phone converts voice into an electrical signal that travels through copper wires to the telephone company's central office, where it is converted back into sound and sent to the person you are calling. And the very simplest working telephone would look like the image you can see on this slide. And as you can see, it only contains three parts, which they are all simple. You can see a switch to connect and disconnect the phone from the network. This switch is generally called the hook switch, and it connects when you lift the handset. We can see a speaker. This is generally a little 8-ohm speaker of some sort. And a microphone, of course. In the past, telephone microphones have been as simple as carbon granules compressed between two thin metal plates, and sound waves from your voice compress and decompress the granules, changing the resistance of the granules and modulating the current flowing through the microphone. That's it. You can dial this simple phone by rapidly tapping the hook switch. All telephone switches still recognize pulse dialing. If you pick the phone up and rapidly tap the switch hook 4 times, the phone company switch will understand that you have dialed a 4, for example. The only problem with the phone shown above is that when you talk, you will hear your voice through the speaker, so any real phone contains a device called a duplex coil or something functionally equivalent to block the sound of your own voice from reaching your ear. A modern telephone also includes a bell, so it can ring, and a touch tone keypad and frequency generator. Something like this. So still, it's pretty simple. In a modern phone, there is an electronic microphone, amplifier, and circuit to replace the carbon granules and loading coil. The mechanical bell is often replaced by a speaker and a circuit to generate a pleasant ringing tone. But a regular phone remains one of the simplest devices ever. So let's talk about the LandLine network, and let's indicate all the points where eavesdropping can happen on a LandLine network. I just want to stress out that different countries might have different technologies for the distribution of landline lines, and so I describe here the most comprehensive network, but it can be a little different in some geographical areas. So the first point is the landline phone itself. Usually, it connects via phone cable with a connector of the type RJ11 to an outlet in the same room of the landline phone. The twisted pair cable can have the color of, for example, of red and green, but the cable can have more wire pairs with different colors, for example, yellow and black, for example. To allow the transmission of more long-distance calls, the frequencies transmitted are limited to a bandwidth of about 3000 hertz. All of the frequencies in your voice below 400 hertz and above 3400 hertz are eliminated. So you can check the lesson on acoustic espionage system to get more information on sound of voice frequencies. That is why someone's voice on a phone has a distinctive sound. We differentiate between an analog transmission, where the signal is analog until the regional concentrator switches, but the signal can also be digitized in the landline phone circuit itself and continue its way up to the regional concentrators, where it will be combined on a T1 or E1 cables up to the central switch. But there are also solutions where the digital E1 or T1 digital transmission can start at big buildings or even big offices up to the central offices. So there are many combinations, and really what I am going to describe here is a general idea, which, as I said, can be different for specific cases. So I've seen, let's talk about the device itself, the phone itself. I mean, we will start with the phone itself, but we have, of course, other points that we will describe along this lesson. So first, I've seen several ways to bug the landline phone itself, but one of the more sophisticated was where the analog voice captured from the microphone on the handset is being transferred on the phone internal circuit to one of the three twisted pair wires that the telephone cable has, and then being captured along the line. So you have to know that the signal between the handset or the hook and the phone base is analog, so it is not decoded or coded until it gets to the phone base circuit, where it is being encoded. If this is a digital phone, but when you take the analog signal on the circuit and you redirect it to a free twisted wire, then the signal continues unencoded as analog signal and captured in some points of the telephone cable. Depending on the cable, it can have 2 or 3 or 4 twisted pairs wires, but only one will be used for the call itself. So the analog signal can be easily transmitted on one of the 3 wires of the cable. So in the case that I am describing, the bug was even more sophisticated, because when the hook was in place, when the handset was in place, it made the internal speaker turn to be a microphone by just giving it some voltage. So the room audio was transmitted constantly on the free wire, and when a call was placed, the wire transmitted the analog call captured from the handset. If you ask yourself how this kind of bugging can be discovered, the answer is by analyzing the internal electronic circuit on the base of the device, of the phone itself, And in this case, we were able to see some wires that were welded in a way that it was obvious that this is not part of the original design of the circuit. So we asked the client to take it for our lab, where we were able to analyze it better with professional equipment, and the actual modified function was revealed. So this is just to stress the point that the eavesdropping can start from the LandLine device itself, and the internal circuit must be analyzed. The phone, you have to open the phone and check the internal circuit and see if the circuit, the electronic circuit, does not look that something has been changed of it, and it should look like a professional printed circuit with no something that will look strange from the point of the internal structure of the circuit. Okay, this is one point, and then we have the PABX. It's another point where there is a need to be careful, since it is a point where any line of the company can be recorded or redirected to another point where any call can be recorded. So this is the PABX, and we have the internal distribution box. And this is usually can be seen in big buildings where there are many apartments or offices, and it can serve one floor or several floors. So you can basically connect a recorder to any of the lines that pass in the box, and record the lines of other users of higher floors, since all lines of higher floors pass in this box and continue to the lower floor. So then we have the building distribution box. The distribution box of a building receives the lines from the street distribution box and pass it to the subscribers. We can see on the left, on the black patch panel, the lines that comes from the street distribution box, and on the right the orange patch panels that contains the lines that goes to the subscribers. Any line in this box can be connected to a recording device or transmitted in various forms to another monitoring destination. So the next one is the street distribution box, and this is usually get the lines that comes from several buildings and connect it to one cable that goes to the regional concentrators switches. So these boxes are supposed to be closed and have access only to the telephone maintenance providers, but in fact I have seen a lot of cases in different places where private detectives were able to open these boxes and leave recorders inside connected to a specific line of interest, and then collect it later on. So this is another point where eavesdropping can be executed. And then we have the regional concentrator switches that receives the cables from the street distribution boxes and also perform the conversion from the analog signal to a digital signal, which enable it to transmit a lot of calls on T1 or E1 cables to the central switches of the operators. So the concentrator digitizes voice in the form of analog signal at a sample rate of 8,000 samples usually, 8,000 samples per second, and 8-bit resolution, meaning that each sample is composed of 8-bit. So I never saw or heard on a possible way to get into these switches and apply some listening devices. This might be possibly something that might be operated by government espionage agencies, probably. And then we have the central offices, of course, that collects the call traffic from the regional concentrators and transmit it to the central switch that is the closest to the target subscribers, from which the call makes the opposite way until get to the phone device of the target subscriber. So your voice normally travels over a fiber optics line to the office of the receiving party. But it may also be transmitted by satellite or by microwave towers. Now, regarding central office, I just want to say that I've seen cases where internal workers of some telephone companies did some, let's say, illegal services doing recordings of specific lines. Of course, in illegal activities, and this is not, of course, a general, it's not happening in general, but I've seen cases of this that were exposed in the media, and probably a lot of cases that happened and were not exposed. So this stuff can happen as well in some regions in the world, but I'm not making any generalization of this issue, but it can happen. So these are the general description of points that where eavesdropping can be made and bugs can be used. But this is a very general description. There might be cases of, depending on the region and local technical regulations of the network, and depending on the type of service that you contract from the telephone operators, because there are a lot of types of services. So I just wanted to make a general description, and the network might have parts of these components or maybe some other parts. But these are the main parts that we can see in most of the networks.